is lesson 3.8. Last time we learned about the sine law and we saw how much easier it makes solving for different sides and angles in a triangle. And the most amazing part of it was that it works for any triangle. We're not just talking about right angled triangles anymore. It could be any kind of triangle. But as you're going to see in a minute here, sometimes the sine law doesn't quite work. So that's where the cosine law is going to come in, and that's what we're talking about in this lesson. It's honestly one of my favorite formulas to use because it's basically the Pythagorean theorem on steroids. Anyways, let's just get into an example. So this is our triangle ABC. They give you two sides, 6 and 3, and an angle in between them, 36 degrees. They want you to find the length of BC, which if we use the notation from last class, that would be side little a. So if I start setting up the sine law, if I want to find little a, then I'm going to have a over sine of the angle opposite to it, so that'd be sine of 36 degrees. And that's going to be equal to, now I could use side little b, so that's going to be 6 over the sine of angle b, but I don't know what the angle b is. So if you were to cross multiply this, it's not going to work because you're looking for little a, but you need to know what the value of angle b is. Otherwise, you're going to have two unknowns in a single equation. That's not going to give you an answer. You can try all you want. Similarly, I could use side little c, which would be 3 over the sine of angle C, but again, I don't know what C is. So in this case, the sine law is not going to work. So we have to come up with another way of finding side little a. So let's scroll down to the first example here. What we can do is we can draw another couple set of lines here. So I'm going to drop a perpendicular from C and then connect, and so that's going to be a new point D in the corner here, and then connect that with a horizontal line to B. And you can see that we've created a right triangle by doing this. Actually, we've created two right triangles. We've created the small one and the big one, which is ACD. And the side that we're looking for, which is little a, that's the hypotenuse of triangle BCD. So what we could do is we could find BD and CD, and we could use Pythagoras to get the hypotenuse, which is A. So that's the plan. So the first thing that I want to do is I want to find CD. And to do that, I'm going to be looking at the big right triangle here. So that's triangle ACD. And I notice that, okay, I have CD here, which is opposite to the angle 36, and 6 is the hypotenuse if I'm looking at the big triangle. So I can set up a sine ratio. I can say that the sine of 36, that's going to equal CD over 6. And so at this point, the side CD is pretty easy to find. I'm going to multiply both sides by 6, and I get that CD is equal to 6 sine of 36. You work that out, and it's going to be approximately 3.5276. Or 5267, excuse me. So we found CD, and now the next thing I'm going to find is AD. And you might be thinking to yourself, well, we need to find BD, so why are we finding AD? Well, if I find AD, then I can subtract 3 from it, and that's going to give me BD. So it's kind of an indirect way of finding BD. So looking at the big triangle ACD again, AD is adjacent to 36, and so I'm going to set up a cosine ratio. The cosine of 36, that's going to equal AD over the hypotenuse of the big triangle is 6. So again, multiplying both sides by 6, I'm going to get that AD is equal to 6 cosine of 36. And that's going to give me 4.8541. All right, so if that's AD, then that means that BD is going to be the number I just found, so that's the 4.8541. And I'm going to take off 3 from that to get the leftover bit. So that's going to land us at about 1.8541. So these are the two numbers that I need now to plug into the Pythagorean theorem with triangle BCD to get the hypotenuse, which is little a. That's the thing that I've been after the whole time. So I can say in triangle BCD, we have that BC squared, so that's my little a squared, and that's the hypotenuse. That's going to equal the BD squared plus my CD squared. These are the numbers in yellow that I highlighted. So if you plug those numbers in, double check on your calculators, you should get about 15.8753. And that's equal to a squared, but I want a. So a is going to be the square root of that number. So you plug that in and you round to the nearest tenth, you're going to get about 4.0. And so there you have it. We found the answer. But to be honest, this was a lot of work to get the answer. The cosine law, which is what we're talking about today, is going to offer a much faster and easier way of doing something like this. So let's go on to the next page to find out what that is. All right, so I've gone ahead and highlighted the formula for you. It looks a little bit messy. A squared is equal to b squared plus c squared. So that kind of looks like Pythagoras. But then you have this little extra bit tagged on at the end. Minus 2bc cos of a. That looks like a lot to memorize, but honestly, once you start using this formula, it's actually quite easy to remember. In this video, I'm not going to be talking about the proof, which you see down below here. I might save it for in class, or I might just not talk about it at all, but if you're interested in it, I'd love to have a conversation with you and we can figure out where this equation exactly comes from. But for the sake of this video, we're just going to take it for granted. So I'm actually going to get you to flip the page to 233 and jump into example 2. So here in example 2, we have the exact same triangle that we did in example 1, but now I'm going to show you how much easier it is to find that side little a right here using the cosine law. And I should backtrack a little bit to page 232. I forgot to mention this little note here. I'm going to put a star by it. It says, this version of the cosine law can be used in any triangle if you are given the lengths of two sides and what's called a contained angle. So this is called a side angle side triangle. So if you look at example 2 here, you have two sides and you have an angle sandwiched in between those two sides. So that's what we call a side angle side triangle. And that's going to be an indicator on when to use the cosine law as opposed to the sine law. But more on that later. Anyways, according to the cosine law, if we want to get a, then I'm going to set up the cosine law as a squared is equal to the other two sides squared and added together. So b squared plus c squared minus 2 times the other two sides as well, BC, and then we have the cosine of A, which is the angle opposite to the side that we're interested in. So I just have to plug these numbers in, and it's literally as simple as that. So B in this case is 6, so I have 6 squared plus little c squared, so that's 3 squared, minus 2 times 6 times 3, and finish it off with multiplying by the cosine of 36, which is angle A. So this is just a matter of plugging it in. So we can do all the calculations in one line. You're going to get that a squared is that 15.8753 number that we found earlier, which you take the square root of that and you get that a is 4.0. So as you can see, a lot faster and a lot easier than all the work that we did in example 1. So let's move on to example 3. It says, consider a triangle PQR, so that's down below here. Part A, complete the cosine law for calculating side little q. So according to the cosine law, that's going to equal the other two sides added together, but we're adding up their squares. So I should have p squared plus r squared minus 2pr cosine of capital Q. So I'm just going to label the diagram with the information that they've given us. So side QP, which is really side little r, that's 1.7. QR is little p, so that's p is equal to 3.1. And angle PQR is 110 degrees, so that is over here. So notice that we have a side angle side triangle. The angle is sandwiched in between two sides. So we're going to use the cosine law. So we are looking for side little q. So I'm going to go ahead and use the formula that I just wrote down. So q squared is going to be p squared, so that's 3.1 squared, plus 1.7 squared, minus 2 times 3.1 times 1.7 times the cosine of capital Q, which is 110 degrees. You punch those numbers into the calculator, you're going to get 16.104 dot dot dot, which I'm then going to take the square root of that number, and you should also get about 4.0 when you round it. That's not connected to example 2 in any way, we just happen to get the same number for this question as well. All right, let's move on to example 4. All right, it says that Bellevue is 30 kilometers north of Ayr. Ayr is, I believe, a city in Ontario. And Churchville is 18 kilometers northwest of Ayr. Calculate the distance between Bellevue and Churchville to the nearest kilometers. Okay, I need a picture. So it seems that the city of Ayr is the reference point because they're describing Bellevue and Churchville. They're describing the distance from Ayr for both of those cities. So I'm going to go ahead and stick Ayr over here. And in fact, I'm just going to say A for Ayr. And it says that Bellevue is 30 kilometers north of Ayr. So that means that Bellevue is going to be straight up here. And I'm going to say B for Bellevue. And that distance right there is 30. In fact, I'm just going to say 30 kilometers. Okay. And then Churchville is 18 kilometers northwest. Okay. So whenever they say northwest, that means exactly 45 degrees. In the northwest direction. So that means that Churchville, which I'm going to label with a capital C, this distance right here, if I can draw a straight line, that distance right there is 18 kilometers. And this angle right here is 45. So that's what northwest means, exactly 45 degrees. Okay, so then they want us to calculate the distance from Bellevue, so that's B, to Churchville, C. So we're basically trying to find little a in this diagram. That's what we're trying to find. So again, we have a side angle side situation going on. So that tells me that I'm going to use the cosine law. So let me set up the cosine law for side A. It's going to be a squared is equal to b squared plus c squared minus 2bc cosine of capital A. So at this point, it's literally just plug and chug. So little b is 18. So I have 18 squared plus 30 squared minus 2 times 18 times 30 and the cosine of the angle, which was 45 degrees. And that's going to work out to be about 460.32, etc., etc. It's going to give you a bunch of decimal places. So now I take the square root of that and I get 21.45 yada yada yada, but they want it to the nearest kilometer. So that is approximately 21 kilometers away. Let's go on to the next page. So sometimes you're not looking for a particular side. Sometimes you're going to be looking for an angle. So you can take this this formula here, a squared is equal to b squared plus c squared, etc., etc., and you can rearrange it to isolate cosine of a. Because once you actually work out what the right-hand side of this equation is, to actually get the angle, you would take the inverse cosine. But anyways, we're gonna see what that looks like in a second. But just to give you an idea of how we rearrange this, you would take the negative 2bc cos a, and you would bring it over to the left-hand side by adding it. So if you're gonna add 2bc cos of a to both sides. So it would cancel on the right and it would show up as positive on the left. And at the same time, you could take that a squared and you could subtract it from both sides. So it appears as a negative a squared on the right-hand side and it disappears on the left. And after you do that, then you would divide both sides by 2bc and you end up with this equation right here, okay? So you can either memorize that, put that on your cheat sheet, or you can work it out every single time you do a question. But anyways, when you're looking for an angle, more often than not, you're going to be given all three sides of the triangle. So that is called your side, 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 SSS triangle. And it might not be angle A that you're looking for. It might be angle B or angle C. So for cosine of B, the equivalent form of that would be c squared plus a squared, so the two other sides squared, minus b squared all over 2CA. And if you're looking for cosine of capital C, that's going to be the other two sides. So that's going to be a squared plus b squared minus c squared all over 2ab. So let's see how that plays out in the next example. It says determine the largest angle, so we're looking for an angle here, in triangle ABC, and you have all these specifications. So let's draw the picture here. I have some triangle, and I'm going to put ABC like this, and that's going to force my little a to be over here, and that is 14.7, which it's the longest side out of the three, so in the diagram it does look like the longest side. And then my C over here is going to be 12.6, and my little b is 8.9. Okay, so we're looking for the largest angle. And here's the thing. The largest angle, which one's it going to be? It's going to be opposite or across from the largest side. So the largest angle that we're looking for is angle A. So according to the cosine law, because we have a side-side-side triangle, all three sides are given, that's going to indicate the cosine law. So according to this, the cosine of A is going to be b squared plus c squared minus a squared all over 2bc. So let's plug those numbers in. B is 8.9, so I have 8.9 squared plus c is 12.6, so that's 12.6 squared. And I'm going to subtract 14.7 squared. And all that is going to be divided by 2 times 8.9 times 12.6. So it's a bit of calculation to do, but you're going to get cosine of A is going to be equal to you should get 0.975. So that means that the A is going to be the inverse cosine of this ratio, 0.0975, and you're going to get 84 degrees. And there you have it. So one last example to finish things off here. Two ships set sail for port P, heading in different directions. The first one sails 7 kilometers to R, and the second one sails 8 kilometers to Q. Okay, so they've kind of told you everything going on here. The distance between R and Q is 13 kilometers. Determine the angle between the direction of the two ships. So the angle between the two ships, we're going to be looking for angle P in the diagram here. So again, we have a side-side-side triangle. So I'm going to be setting up the expression for the cosine of P. And according to the cosine law, it's going to be the other two sides squared and added together. So that's q squared plus r squared minus p squared all over 2qr. So let's plug those numbers in. I'm going to get 7 squared plus 8 squared minus 13 squared. And all of that's going to be over 2 times 7 times 8. So you're going to get cosine of P is equal to negative 0.5. Okay, so here's the thing though. If you remember from previous classes, cosine is negative in 2 quadrants. So it's going to be negative on the west coast, so that's in quadrants 2 and 3. So I need to get the reference angle first. So my theta r is going to be the inverse cosine of the positive ratio 0.5, and that's going to give you a reference angle of 60 degrees. So that means that theta, well actually I shouldn't call it theta, I should call it angle P. So that means that angle P is either, well, if I'm in quadrant 2, that's going to be 180 minus 60. So it's either 120 degrees or angle P is going to be 180 plus 60. So that would be 240 degrees. So which one is it? Well, 240 is not going to be it because that's more than 180 degrees. And remember that all three angles in a triangle add up to 180 degrees, so it couldn't possibly be 240. So that one's out, and the one that we pick is 120 degrees. So that does it for this lesson. We'll see you in class. Have a good one.